Okay, some more problems on 9.5. This is number 41. And this is our series, n equals 1 to infinity, the summation, x to the n over n times the square root of n, 3 to the n. We're going to start by using the ratio test and testing for absolute convergence. So again, I'll take the limit of the absolute value of a sub n plus 1 over a sub n. And that's going to be the limit, so this would be, every time I see an n, I put an n plus 1. And I'm just going to use the absolute value on the x terms because the n's are always positive. So absolute value of x to the n plus 1, n plus 1, square root of n plus 1, 3 to the n plus 1, and then I just have the reciprocal of this. I'll put this on top. N times the square root of n times 3 to the n over the absolute value of x to the n. Then I can break this up into these two, and I can break this up into those two. This is the same as here. And these that cancel, the 3 to the n's that cancel. And then I group all my n terms together, so I get n times the square root of n all over n plus 1 times the square root of n plus 1. That's these 4 factors all together. And what's left is x to the n, because those canceled, over 3. And the absolute value of x. The x to the n's cancel. So I have x to the n over 3. Now if I take the limit of this as n approaches infinity, these 1's become insignificant, so it just says n over n, square root of n over square root of n, so this goes to 1, times the absolute value of x over 3, which is just the absolute value of x over 3, which equals L. And remember that converges absolutely for L less than 1, or the absolute value of x over 3 less than 1, or the absolute value of x is less than 3, or x is between negative 3 and positive 3. So that's an interval of convergence so far. We need to check the endpoints. Let's see all that. I'm going to tilt my paper there, so we need to check the endpoints. And what I'm going to do is I'm going to try to do plus or minus 3 at the same time for absolute convergence. You can do them separately, or you can kind of group them up, because when we take the absolute value, they're going to end up being the same. So we can take the summation of this. Here we go. So check the endpoints for absolute convergence. So the summation, I'll put plus or minus 3 in here to the n, the absolute value of that over all these. And the only thing that's going to be really affected by the absolute value will be the plus or minus 3, because the n's are always positive. And the absolute value of plus or minus 3 is 3. So we kind of make that into one term. Like I said, if we did it separately, then they would both would end up being this. And we can see that the 3 to the n's cancel, so I end up with 1 over n to the 3 halves, and this converges by the p-series test. P is 3 halves, which is greater than 1, so it converges. So that means the series converges absolutely at both endpoints, x equals plus or minus 3. So this is my interval of convergence. It converges at both endpoints, and it converges absolutely at both endpoints. So there are no values of a conditional convergence. Okay, I hope that makes sense. Think about that. And then 42. And I wrote a few extra steps on here just to make sure it's really concise. It's not that difficult. Again, this was our series. The summation n equals 0 to infinity of x to the 2n plus 1 over n factorial. First we'll use the ratio test again to test for absolute convergence. So again, we're going to do the limit as n approaches infinity, the absolute value of a sub n over a sub n plus 1 over a sub n. And then that's going to be the limit. And every time I see an n, I put an n plus 1. So this is the absolute value of x. And then this is going to be 2, and then it's an n plus 1 plus 1. All over n plus 1 factorial. And then we'll just take the reciprocal of that, n factorial, over the absolute value of x to the 2n plus 1. And then I put a lot of extra steps in here for you to make it real easy. This is going to be 2n plus 2 plus 1, so you can see how that works. And then n factorial, n plus 1 factorial is the same thing as n plus 1 times n factorial. So we realize that from probability and statistics. And then this is the same over here. And then I could kind of rewrite this. I kind of fiddle around and put the 1 next to that, so I ended up with the absolute value of 2n plus 1 plus 2. And then I canceled these n factorials, so I just had n plus 1 over the 2n plus 1. Then I used an extra step to do this. You probably could do it without that extra step. But I wrote this as the absolute value of x to the 2n plus 1 times absolute value of x squared. There's that 2. All over the absolute value, over x plus 1. And then this was over here. And those cancel. So I end up with this. And the absolute value of x squared is going to be positive, so I don't need the absolute value. Bar, all over n plus 1. And I kind of rewrote it so you can see the limit. And the limit as n approaches infinity, this will be 0. So this ends up with 0 times x squared, which is equal to 0. And that's my L. Now remember, this converges when L is less than 1. L is always less than 1. Because 0, which equals L, is always less than 1. So therefore, the series converges absolutely for all real numbers. Okay, so therefore the series converges absolutely for all real numbers because 0 is always less than 1. And that's L. So here's my interval of convergence, negative infinity to infinity. Here's my interval of absolute convergence, negative infinity to infinity. And there are no values of a conditional convergence because they're all absolute convergence. Okay, hope this helps.